Good day, everyone. In this video, I'm going to discuss to you the greatest common divisor, or GCD. So we will be using here the concept of divisibility. Now recall that in our previous video, when an integer a divides an integer b, we can say that for some integer k, we have this notation, we have b is equal to a times k, where a and k are factors or divisors. Okay, and then we can have b is a multiple of a and k, or b is divisible by a and k. Now we will be focusing here on the divisors. So using the concept of divisibility. Now, let's proceed. Two integers a and b, take note that a and b are not both 0, can have only finitely many divisors, and thus can have only finitely many common divisors. In this section, we are interested in the greatest common divisor of a and b. So we note here that the divisors of a and that of the absolute value of a are the same. So I will discuss this later on. Why is it that the divisors of a is the same as the divisors, or the divisors of a are the same as the divisors of the absolute value of a? Now let's have here an example. Definition rather. So the greatest common divisor, or GCD, of two integers a and b is the greatest integer that divides both a and b. Now let's have here an example. So let's have here an example where a is equal to, say, 12, and then our b is 18. Now let's try to find the GCD of 18. So here, by the way, here, we denote the greatest common divisor of two integers a and b by this. And so we can have this one. We will be finding this one, the GCD of 12 and 18. Now let's have first get the divisors of 12. So for 12, so here for 12, we can have 1 divides 12. Why? Because we can write 12 equals 1 times 12, right? And then another one, and also after the, we can say that from this equation here, we can say that 12 divides 12. So we now have here two divisors, 1 and 12. Another one, we have 2 divides 12. Why? Because 12 is equal to 2 times 6. Follow? Therefore, from this, we can also say that 6 divides 12. So we now have 4 divisors of 12. Another one, we can say that 3 divides 12. Why? Because 12 can be written as 3 times 4. So from this, we can also say that 4 divides 12. So we now have here 6 divisors of 12. So next to 3 is 4, but 4 does not divide 12. Oh, 4 rather. 4 next to 3 rather is 4. And we know that 4 divides 12. 5 does not divide 12. So we have 6. And the last is 12. Therefore, the divisors of 12 are, we have 1, 2, 3. We have here 1, 2, 3. Next, we have 4. Next, we have 6 and 12. Follow? Okay. So next for B equals 18. Now let's try to find the divisors of 18. By the way, you can check the pairing. You can check the pairing of divisors so that you might not miss any divisors. Just like this one. Here, this one is paired to 12 because 1 times 12 is 12. Here, okay, 2 times 6 is 12, and then 3 times 4 is 12. So you can do it to check the pairing so that you might not miss any divisors. So let's proceed to 18. So with B is 18, we know that 1 divides 18, and we can write it as 18 equals 1 times 18. From here, we can say that 18 divides 18. Next, 2. 2 divides 18, since we can write 18 equals 2 times 9. And from here, we can say that 9 divides 18. Another one is 3. So 3 divides 18, since 18 is equal to 3 times 6. And from here, we can say that 6 divides 18. So do we have any divisor of 18? Let's try to have 4. 4 does not divide 18. 5 does not divide. 6 divides 18. So we have here 6 and then 9, 18. Hence, we have 6 divisors for 18. So let's write here divisors of 18. We have first 1, 2, 3, 6, 9, and 18. So let's check the pairing. So we might not miss any divisors. So we have here paired to that. 2 is paired to 9, and then 3 is paired to 8, 6. So now from this, we can now get the greatest common divisor. So it is the greatest integer that divides both A and B. So from our list here of the common divisors of 12 and 18, we can say that the greatest common divisor is, we have 6. Follow? Because 6 divides 12 and 6 divides 18. So it is the greatest. By the way, here, as you can see, 2 divides here, 2 or 3. Here, 3 divides this one. 3 divides 12, and also 3 divides 18, right? So 3 divides both 12 and 18. However, we are looking on the greatest integer that divides both 12 and 18. And we have here 6. 6 is the greatest integer that divides both 12 and 18. Therefore, we can write our answer as this one. The GCD of 12 and 18 is 6. So as simple as that. So I hope it is clear to you now. So let's proceed. By the way, we also define the greatest common divisor of 0 and 0 is 0. So we define that here. So the GCD of 0 and 0 is 0. So let's have here another example. So we note that the greatest common divisor of 24 and 18 is 6. So you can check this using the concept of divisibility as what I have did a while ago. So it is written as this. So here there are couples of integers such that 3 and 4 whose greatest common divisor is 1. So we call such integers relatively prime integers. So here, two integers, a and b, are relatively prime if a and the GCD rather of a and b is 1. Okay, so let's have here another example. So for example, if we have here a equals 5 and we have b equals 7, notice that 5 is a prime number, 7 is a prime number. Hence, the only divisor of 5 is 1. And also the divisor of 7 is 1. Therefore, so for 5, the divisors of 5 are 1 and itself, 1 and 5. Here, the divisors of 7 are 1 and itself. So let me write it here. So we have 1 and 5. Here, the divisors 1 and 7. Therefore, the greatest common divisor, we have 1. So we can have 5. The GCD of 5 and 7 is 1. Okay. Hence, we can say that 5 and 7 are relatively prime. Okay. Now, notice here that 5 and 7 are prime numbers. Hence, all prime numbers are relatively prime because we know that a prime number has divisors 1 and itself. Follow? So except if a and b are the same, right? So for any prime numbers, say for example, any prime numbers a and b that are not the same, so the GCD is always 1. And hence they are relatively prime numbers. However, all relatively prime numbers are not necessarily prime numbers. So just like for example, let us consider a be equal to 9 and then b be equal to 16. Notice 9 and 16 are not prime numbers. Now we will try to check if they are relatively prime. So let's try to check the divisors of 9. Okay. So here, we know that 1 divides 9. What else? 3 divides 9. And 9 divides 9. Therefore, the factors or divisors of 9, we have 1, 3, and 9. Okay. So here for 16, we know that 1 divides 16. Next to this is, what's the pairing of 1? We have 16 divides 16. Next, 2 divides 16. So 2 times what number equals 16? We have 8. So 2 times 8. So we can say that 8 divides 16. Another one, 3 does not divide 16. So we have 4 divides 16. So 4 times 4. So it's okay. 4 here divides 16. And that's it. We're done with the pairing. So hence here, the divisors of 16 are 1, 2, 4, 8, and 16. So that's it. Now, as you can see here, the greatest or the GCD of 16 and 9 is 1. So we have here 1. So we don't have 3 here. So it means we have here 1 divides both 9 and 16, and 1 is the greatest common divisor of 9 and 16. Hence, we can write the GCD of 9 and 16 is equal to 1. Hence, we can say here 9 and 16 are relatively prime. So take note, not necessarily all prime numbers. We can also have, they are not prime numbers, but then they are relatively prime. So in our first example, of course, all prime numbers are relatively prime. Because again, the only divisors of a prime number are 1 and itself. So hence, the greatest common divisor is 1, or the GCD of any relatively prime numbers is 1. Therefore, any prime numbers are relatively prime. However, the other way is not true in general, because there are also some numbers, just like 9 and 16, that are not prime numbers. They are not prime numbers, right? 9 and 16. However, we have found out here that they are relatively prime. So again, for two integers to be relatively prime, it should be that their GCD, here, GCD is 1. Next, note that every integer has a positive and negative divisors. That is, if A is a positive divisor of M, then negative A is also a divisor of M. So let's try to consider our previous example here. So we have here when A is 12. Now take note here that the divisors of A are here 1, 2, 3, 4, 6, and 12. Also, negative 1, negative 2, negative 3, negative 4, negative 6, and negative 12 are also divisors of 12. Why? Because this one, we can also write this as 12 equals negative 1 times negative 12. Hello? So also negative 1 and negative 12 are divisors of 12. But then, notice that we only consider here positive, because our goal is to find the greatest common divisor, right? Now, if we will consider negative values here, so we will get the positive one, right? Because if negative 6 is a divisor of 12, so with 6. But then we are looking at the greatest common divisor. So we are looking the greatest common divisor of a number. Hence, we will just consider positive numbers in that case, okay? We have here, using the definition of the greatest common divisor, we can see that this is true. Okay, so since, say for example, if we have here, say we have here negative 12, then negative 18. So we are to look for the greatest common divisor. So take note here that the divisors of negative 12 and 12 in our previous example are the same. They are the same. Why? Because negative 12 here, this one, negative 12, can be written as the product of, say, negative 1 and 12. We have negative 12 is the product of, say, 3 and negative 4. Or we can switch. We can have negative 4 times 3. Therefore, they have the same divisors. Hence, this is equal to the GCD of 12 and 18, which is equal to 6. So we have this one, absolute value of A, where A here, in our example, A here is negative 12, B is negative 18, and then its absolute value is 12 and 18. So they have the same GCD. Take note, because we are considering the greatest common divisor. For example, we have here, let A be negative 6, B be negative 5. Then we have the greatest, this is the notation for our GCD, which is equal to this one. So you can check it, which is equal to 3. Then we can restrict our attention to greatest common divisors or pairs of positive integers. So we can consider, say for example, the given numbers or integers are negative, we can consider the positive of the given. So let's end with this. There will be a continuation of this on my next video lecture, where there I'm going to present some results about the greatest common divisor. So thank you for watching and listening. God bless everyone.